The contaminant's name is lead. The structure of lead has 82 protons, 125 neutrons, and 82 electrons. The electronegativity is 2.33. The structure of lead is pictured above to the right. The molar mass of lead is 207.2 thousand grams per mole. We can see this on the periodic table. For slide 3, we must convert the concentration into units of molarity using the highest level detected. So in the case of lead, we are going to use 3 parts per billion of lead, which is 3 grams lead over 1 billion grams of H2O. So we first must convert 3 grams of lead to moles, and we will do that by dimensional analysis, which then gives us a number of 0.0144787.645 moles of lead. And next, we need to convert 1 billion grams of H2O to liters. So there's 1,000 grams in 1 liter, so we will divide 1 billion by 1,000, which gives us 1 million liters of water. Now we will divide our moles of lead by our 1 million liters of water. So we do that, and we get a molarity of 1.4 times 10 to the negative 8. For slide 4, molecules calculation, how many molecules of lead are in a 20,000 gallon water tower? So to find this out, we first must convert our molarity from slide number 3 to molecules using dimensional analysis, which then gives us 8.4 times 10 to the 15th molecules of lead. Next, we need to convert liters to gallons, and there's 1 liter in 0.26 gallons, and since we're using our concentrations from slide number 3, we are going to use 1 million liters, and in 1 million liters there's 264,172.052 gallons. So now we are going to divide the molecules by the gallons. So by doing that, we get a large number, which is 3.179745903 to the 10th. However, we only need 20,000 gallons, so we will divide that number by 20,000, which gives us 1.6 times 10 to the 6th molecules of lead in the 20,000 gallon water tower. For slide number 5, we needed to represent lead in a Lewis dot structure or diagram, which is located on the bottom right side of this slide. And from this diagram, we can see that lead has 4 valence electrons, which means it has the potential to create up to 4 chemical bonds with other elements. In addition, because of the formation and presence of only 4 valence electrons, lead tends to make single covalent bonds.
Chemical properties of lead. Physical properties of lead include bluish-white lustrous metal, soft, highly malleable, ductile, poor conductor. Chemical properties of lead include its atomic number of 82, low melting point, chemical symbol of Pb, boiling point of 3,180 degrees Fahrenheit or 1,749 degrees Celsius. Lead can separate from water by reverse osmosis, distillation, and carbon filters. Here is an image of chemical features of lead. Its atomic number is 82, which is in the top left corner. Its atomic weight is 207.2, which is in the top right corner. Its symbol is Pb, which is located in the middle, and its name is in the bottom left corner, which is lead. Here are some images of physical features of lead. In the photos below, you can see its grayish-blue colors. Contamination source of lead. The likely source of contamination is corrosion of household plumbing systems, erosion of natural deposits. In the West Bank, the main culprit of lead in the water system is improvements of roads allowing lead to get in the water pipeline. This picture shows the West Bank of New Orleans and all the roads and roadworks surrounding it, causing contamination of the water. As you can see, there are many roads surrounding it, along with houses, which is allowing lead to get into the water source, making it contaminated.
The health effects of lead. General exposure. General exposure to lead accumulates in bone and body organs once it enters the body. Elimination from the body is slow. Initial and periodic medical examinations are advised for persons repeatedly exposed to levels at or above the exposure limits of lead dust or fumes. Once lead enters the body, it can affect a variety of organ systems, including the nervous system, kidneys, reproductive system, blood formation, and gastrointestinal system. The primary routes of exposure to lead are inhalation or ingestion of dust and fumes. Acute exposure. Acute exposure to the skin or eye. Contact with dust or fume may cause local irritation but would not cause tissue damage. Inhalation. Exposure to lead dust or fume may cause headache, nausea, vomiting, abdominal spasms, fatigue, sleep disturbances, weight loss, anemia, and pain in legs, arms, and joints. An intense, short-term exposure to lead could cause acute encephalopathy with seizures, coma, and death. However, short-term exposures of this magnitude are unlikely in industry today. Kidney damage as well as anemia can occur from acute exposure. Ingestion. Symptoms due to ingestion of lead, dust, or fume would be similar to those from inhalation. Other health effects, such as metallic taste in the mouth or constipation or bloody diarrhea, might also occur. Chronic exposure. Prolonged exposure to lead, dust, and fume may produce many of the symptoms of short-term exposure and may also cause central nervous system damage, gastrointestinal disturbances, anemia, and rarely wrist rot. Reduced hemoglobin production has been associated with low lead exposures. Symptoms of central nervous system damage due to moderate lead exposure include fatigue, headaches, tremors, and hypertension. Very high lead exposures can result in lead encephalopathy with symptoms of hallucinations, convulsions, and delirium. Kidney dysfunction and possible injury has also been associated with chronic lead poisoning. Chronic overexposure to lead has been implicated as a causative agent for the impairment of male and female reproductive capacity. Pregnant women should be protected from excessive exposure as lead can cross the placental barrier and unborn children may suffer neurological damage or development problems due to excessive lead exposure. The diagram to the top left shows the body system and the various systems and regions it can affect due to lead poisoning. The lower left photo shows the brains of adults who were exposed to lead as children. Their brains show a decreased volume.
Safety procedures of when dealing with lead. Minimize exposure. Wash hands and face. Don't eat, drink, or smoke in or around areas where lead is stored. Handling and storage. Keep inventories routinely checked, routinely decontaminated work surfaces. Water sample. Maximum contaminant level is 0 because lead is harmful to humans. Have your water tested. Ask, does my water have lead in it above EPA's action level of 15 parts per billion ppb? Does the service pipe at the end of the street have lead in it? If the answer is yes, you need to get your water fixed and checked out. To get rid of lead, run a shower's water for 5 minutes on cold, followed by kitchen tap water for 2 minutes on cold. Here are some images of safety procedures. In the left photo, they are washing their hands to prevent any lead on getting onto them. In the right, they are wearing gloves to prevent skin exposure to lead. And in the bottom right, they are cleaning laboratories after use of lead.
For slide number 10, it asks how many grams of lead are present in an 8-ounce glass of tap water. The answer to this is 1.1 times 10 to the negative 14th grams. To get this, we first must convert our moles of lead into grams using dimensional analysis and values from slide number 3. Next, we convert our liters to ounces, the liters that we used in slide number 3, which then gives us 33,814,022.7 ounces. Then we take our grams, which is 2.9 times 10 to the negative 6 grams of lead, and divide that by our ounces, 33,814,022.7, which gives us a number of 8.6 times 10 to the negative 14th. And then since we want to know how many grams of lead are in 8 ounces of water, we divide that quotient by 8, which then gives us 1.1 times 10 to the negative 14th grams lead in 8 ounces of water.